Okay, so in the previous video, I went over this little example right here, where we have limits as x goes to infinity, and what I was showing you is what happens when the degree of the numerator and the degree of the denominator can, whether they're greater than, less than, equal to, whatever. So this not only helps us define what these limits are, but it also tells us exactly where do the horizontal asymptotes lie within some of our examples. So if I just scroll down here, here's our table right here. This is going to tell us the end behavior, the end behavior of asymptotes and rational functions. So suppose that f of x equals p of x over q of x, where they are both rational functions. Okay. The key here is, p of x is going to be a polynomial, q of x is a polynomial. And if what you're really looking at, just let me get this here. What you're looking at are going to be the degrees of the numerator and denominator. So if m is less than m, meaning m is the degree of the numerator, n is the degree of the denominator. So if m is less than n, you have a horizontal asymptote at y equals 0. If the degrees equal each other, then I'm going to get a little, maybe I should use a different color here too. I like that. So if m equals n, then you're going to look at those leading coefficients of the numerator and denominator respectively, and it's going to be the line y equals a over b. And then lastly, which is the last one, obviously, that's why I said lastly. Sometimes I'm so redundant with things. Like I say things twice or three times. I'm sorry for that. I try to get better at it, but the older I get, the more mistakes I make like that. I'm to the point now where I just don't really care about it anymore. So lastly, if the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. So let me show you some examples. Okay? We're going to fly through this now, which is actually really, really cool. So for example, we're going to find the horizontal asymptote. And what I'll do is with some of these, I'll go ahead and graph them in Desmos so you can see what they look like. So the first example, we'll just call it example 1. F of x equals 3x squared minus 7 all over x squared minus 5x. So if we think about this, the limit as x approaches infinity of 3x squared minus 7 all over x squared minus 5x. Well, when we look at this, I can see that here's my leading coefficient in the numerator. Here's my leading coefficient in the denominator. Since the degrees are equal to each other, not only does the limit equal 3 over 1, but I'm going to have a horizontal asymptote at the line y equals 3. So let me show you what that looks like. Let me go over to Desmos here. Let's get rid of this example. Let me kind of just zoom out and try to standardize this a little bit. Actually, here, I think it'd be easier if I just type in what I need. So I want x to go from negative 10 to 10. And then I want y to go from negative 10 to 10 also. So we're just giving a nice standard XY grid. So, excuse me, the problem was 3x squared minus 7, and then x squared minus 5x. X squared minus 5x. All right, so here's what it looks like graphed. Now, we said that our horizontal asymptote is going to lie on the line y equals 3. So y equals 3. And what I'll do here is I'll change it so it's a nice dot. So give me a second. Dotted line. Get rid of this. And as I zoom out here, you can clearly see that I do have a horizontal asymptote at y equals 3. Okay? Now let's look at the next example here. We'll do a couple of these. Like I said, they're pretty easy. We're actually gonna, like I said, blow through them. So let's try number 2. f of x equals 2x plus 1 all over 3x to the fourth minus 2. Well, think about this as the limit as x approaches infinity of 2x plus 1 over 3x plus 4. I'm sorry, 3x to the fourth minus 2. Get out my highlighter real fast. There's my leading coefficients, or leading terms, for the numerator and denominator. Clearly, 1 is less than 4 in terms of degree. So, y equals 0 is going to be my horizontal asymptote for this example. Go ahead, graph it, tell me what you get. You should come up with the same exact thing, y equals 0. So the third example here I'm going to look at is going to be, let's see, I did one. Okay, yeah. So we'll keep this one simple. How about 40 x to the fifth plus 1 all over 16 x to the fourth minus 2x. So get at the highlighter just one more time. Leading coefficient, or leading term in the numerator, leading term in the denominator. Obviously, 5 is greater than 4, so this implies that we do not have a horizontal asymptote at all. Okay? Now, the last thing I kind of want to go over is just the end behavior of some transcendental functions like e to the x, e to the negative x, ln x. And to be honest with you, if you just know what these graphs look like, these are the parent functions, then you already know what their limits are when you evaluate them. So, real quick, this is a graph of the function y equals e to the x. This is a graph of the function y equals e to the negative x. And here's a graph of the natural log of x. For the first two, the point in question, or better yet, the y-intercept is going to be 0, 1 for both. For the last, we have an x-intercept at 1, 0. So, as you can see here, the end behavior for e to the x, e to the negative x on negative infinity to infinity, and the natural log on 0 to infinity is given by the following limits. So, as x gets larger and larger and larger, e to the x goes to infinity. As x gets larger and larger and larger, e to the negative x goes to 0. And the reason for that, do a little bit of math here. Remember, when you have a negative exponent, you could rewrite it as 1 over the base raised to a positive exponent. So you basically have 1 divided by an extremely large number, and that goes to 0 as well. And then for the ln of x, it always gets larger and larger and larger, but it does it like very slowly. But we're not worried about how fast does it get larger and larger and larger. We just know it gets larger. So that's going to be it for section 2.5. I'm going to go ahead and start making a video for our last section, which deals with continuity, which I think pretty easy to understand as well. See you in the next one.